You know, have you ever just stopped and wondered why our universe is built from these particular particles? Why an electron and not something else? Well, today, we're going to dig into a pretty wild idea that says the particles we see aren't fundamental at all. They're just the survivors. Okay, so let's get right into it. The standard model of particle physics, it's our best ever description of the universe's building blocks. It gives us this whole laundry list of particles. You've got your quarks, your leptons, your bosons, and honestly, it works spectacularly well. But doesn't it feel a little random? It doesn't tell us why we have this specific set. So today we're exploring a fascinating, really speculative idea that tries to answer that exact question. So here's the game plan. First, we're going to unpack the puzzle itself. Then we'll look at particles in a new way, as survivors, and we'll go through the 5 rules they might need to follow just to exist. And finally, we'll see if this whole idea actually maps onto the universe we see around us. Right, section 1, the puzzle. Look, the standard model is an absolute triumph of physics, no doubt about it. But it leaves us with this huge, nagging question. Why this cast of characters? Why do we have these specific particles and not, countless others? And this is where we have to flip our thinking on its head. What if we stop seeing particles as these tiny, fundamental little dots that were just there from the beginning? What if, instead, they're emergent systems? What if they are actually the winners of some kind of cosmic competition, stable patterns that stick around because they follow a much deeper set of rules for existence?
So this whole idea of cosmic survival, it really hinges on 2 big and, speculative concepts. Let's break them down.
Okay, first up is something called constraint resonance emergence theory, or CRET. Now forget the fancy name for a minute, just imagine you hit a piano string. For a split second, there's a total mess of chaotic vibrations, right? But then one clear, stable musical note emerges from the chaos. Well, this theory suggests particles are just like that note. They aren't fundamental dots, they're the stable patterns that win out from a deeper, much more complex reality. And when one of those patterns becomes stable enough and self-maintaining, well, that's when it achieves what's called emergent autonomy. It's not just a random flicker of energy anymore. It's a real, persistent, predictable thing. So an electron, in this picture, isn't just a point. It's a system that has literally won the right to exist. All right, so if particles are survivors, what's the rule book? What are the selection principles these resonant patterns have to follow to become stable, autonomous things? Well, this theory proposes 5 of them, 5 fundamental factors. You can think of these as the absolute criteria for existing in our universe. Any pattern that can tick all 5 of these boxes gets to be a particle. And any pattern that can't, well, it just fades back into nothing. These are the secret rules we're going to decode. Okay, this is the moment of truth. How does this theoretical framework actually connect to the real world? We're going to take each of these 5 rules, one by one, and see if they can explain the actual particles we find in our universe. This is where it gets really, really cool. First step, Rule 1, viability. And this one, well, it's pretty straightforward. To exist, you first have to be able to stick around. It's all about stability, persistence over time, a kind of physical homeostasis. This one simple rule might just explain why our particle zoo isn't infinite. I mean, for every stable electron that we see, there could be countless other mathematical possibilities that are just too unstable. They're unviable and decay almost instantly. So viability acts as the first great filter of reality. Okay, rule number 2 is about being a consistent, reliable building block. For something to be truly autonomous, it needs to be self-contained and totally predictable in how it interacts with everything else. This puts a whole new spin on something we usually just take for granted: conservation laws. You know, you're always told charge is conserved or momentum is conserved. But have you ever asked why? This theory suggests an answer. It's a requirement for existence. Only particles that have these reliable, predictable behaviors can form a stable reality. Without this rule, the universe would just be an unpredictable mess. All right, Rule 3 is a bit more abstract, but it is incredibly powerful. It's all about minimizing surprise, about maintaining consistency no matter how you look at the system. So in physics, we have these deep ideas called symmetries. All it really means is that the laws of physics don't change whether you're here or on the other side of the galaxy. This theory says that's not just a neat mathematical trick, it's a survival requirement. Stable particles have to conform to these deep symmetries, these laws of least surprise, and that might be the fundamental reason our universe is so orderly and predictable. Now, for rule number 4, and this one is really mind-bending. It suggests that the systems that survive are the ones that keep their future options open, that preserve their potential for what they can do next. Just think about it for a second. A photon, why is it massless? Well, maybe having zero mass is what gives it the maximum possible range and speed, preserving the most options for communication across the entire cosmos. And what about a neutrino with its tiny, tiny mass? Maybe that's just enough to preserve a minimal set of future possibilities. This rule connects a particle's deepest properties to its actual role in the universe. And finally, our 5th and final rule. It's all about economy. Simply put, nature is not wasteful. The systems that last are the simplest ones that can get the job done. And this could be the ultimate answer to that question we started with. Why these particles? Because maybe this specific collection, the quarks, the leptons, the whole shebang, is the most resource efficient, the most economical, and the simplest possible solution to creating a stable, autonomous reality that works within the unique constraints of our universe. So, if these 5 rules define the particles we have right now, what does that imply about the past? Or, more interestingly, about the future? Well, this completely changes how we see the Standard Model. It stops being a static, fixed menu of particles and becomes a dynamic snapshot of our cosmic era. The particles we see today are just the ones that can survive in the universe's current conditions. If you change those conditions, say go way back to the Big Bang or crank up the energy in a particle collider, a whole new set of viable particles might suddenly be able to pop into existence. And really, it all boils down to this one idea, a viability set. The particles in the Standard Model aren't some random list God handed down. No, they are the survivors. They're the ones that manage to check all 5 boxes and follow all the rules within the very specific environment of our universe. And that leaves us with one last kind of spooky thought. If our entire reality is just made up of the things that won the competition to exist, what else might be out there, right now, trying to become real, just beyond the edge of what we can see?